at factoring by grouping. Okay, so this is something that you may not have done yet all that much. It's based on a little bit of one of the sample problems that I went through and told you we'd be addressing it later. If I gave you a four-term expression, so again, if you have a binomial, you look to remove common factors and then see does it fit difference of squares or the sum and difference of cubes. If you have a trinomial, you remove common factors and then you look to see does it fit one of the patterns for a perfect square trinomial. And if you have four terms, what you're going to look to do is, again, always start by remove common factors. So are there any common factors you can remove from all four of these terms? No. So you go to the next step, which is if you have four terms, what you may want to try doing is look to see can you factor by grouping. And the way that will work is if you were to mentally pair the first two and the last two terms together, can you remove a common factor from just that first pair of terms? Yeah, what common factor can you remove from those? A 3 and an x squared. And now remember, anytime you remove a common factor, what's left has to have the same form as the original. So it's two terms. So you're going to have a binomial factor left. So when you remove a 3x squared from this first term, what's going to be left? Just an x. And from this second term, if you remove a 3x squared, what's going to be left? A negative 2. Okay, so now you're done. You just factor by grouping those two terms. And now you're going to look at the other pair of terms. So now when we look at this other pair of terms, are there any common factors we can remove out of that pair? A 5. When we remove a 5 from the first term, what's left? X. And when we remove a 5 from the second term? And now, if you're doing this right, and if it's a problem that can be factored further, what do you notice about these now? And now, when you're treating this as one entire expression, do these two groups have a common factor? Yeah, that common factor is x minus 2. So we're going to remove that common factor, and then you look to see what's left. And what's left is 3x squared plus 5. And so this winds up being your factored form. Now, you don't have linear factors all the way yet because you have this square. So you might look to see, can you factor this expression even further? In this particular case, we're not doing irrational factors. Okay, so you can leave it, or complex factors, which are the negatives or the square roots of negatives. So we can leave it just like this. And it
doesn't matter which way you write it, right?
Which factor goes first? No, it doesn't. Usually I'll write the common one first, just because it fits the form of distributing it out or factoring it out. All right, so if we took another example really quickly, again, because this is something that is newer. If I gave you the following. In this first example, when you looked at the pairs that you made, they were separated by a plus, and there's usually no problems with that. However, when you work with a pair, if you, again, group these, looking at these pair, if there's a negative between them, you just need to be really careful with what you're factoring out. And so let's take a look. If we factor by grouping here, are there any common factors we can remove from these two terms? We can remove a 4 and an x. That means when our remaining factor is going to have the same form, it's still going to be a binomial. And what would remain in the first term? 3a, and in the second term, negative 5b. Okay, so here's our first group. Now let's move to the second group. What common factors can we remove from these two terms? Whatever sign is between them is still going to remain. That's the sign of the factor you're going to remove. So you are going to remove a negative term or negative factor from both of those. So what's the common factor here? 3 and y. So if you remove a negative 3y from the first term, again, you're going to have a binomial factor left inside. What's going to remain? 3a. And here you see, when you remove a negative 3y from this second term, what's going to happen to the sign of that term? It's going to be negative, and so you'll get a negative 5b. B, is that consistent with what you would expect? Yeah, now you have this common factor. If you remove or distribute out that common factor, what's going to be left for the terms of the other factor? 4x and a minus 3y. Okay, and so this becomes your set of factors. All right, now, what happens, though, if instead of seeing what I took out there, what if I wanted to reorder these? And what if I saw that if I switch these two terms, maybe I have common factors here as well. So if I took and I move these two terms, and then factored by grouping, and what could I remove from this first set of terms now? Now I can remove a 3a. If I remove a 3a from this first term, I'm left with a 4x, and from the second term, I'm left with a negative 3y. Now, again, my sign is negative, so I'm going to have to remove a negative factor. What common factor can I remove from these two terms? 5b. So I'm going to remove a negative 5b. When I do from this first term, what's left? And from the second term, I'm left with a... Now, so even though I've moved those terms, what do you notice here? You still have a common factor. So if we remove this common factor, bless you, what terms are going to remain for the other factor? 3a minus 5b. Is that any different from what we found here? No. One of the things with this, and we're going to build on this here at the end of today even further, but what you will see is it doesn't matter how you order that middle set of terms. If you can factor by grouping, you're still going to come up with the same thing regardless of which way you put your terms. Okay. All right, questions on that? That's probably new. You guys may not have done that, but it should be pretty straightforward. Okay, the second thing that I want to look at is trinomials with binomial factors. And this is probably the traditional way that you guys learn to factor. And so the way that this fits is we're going to start if our coefficient, our leading coefficient is a 1. And if you have a leading coefficient of 1 and you're looking for the binomial factors that equal a specific trinomial, and this is where you just do reverse FOIL and trial and error, right? This is what you guys are familiar with. You look to see your first term for each factor is going to be an x, again, if the leading coefficient is a 1. And then your second terms are going to be the two factors whose product is this last term and whose sum is this middle term. So what two factors of negative 12 have a sum of positive 4? Okay. So again, mentally you're looking at, you know the sum is going to be positive, so you know that your larger number has to be a positive. So you're looking at negative 2 and 12, or I'm sorry, negative 1 and 12, negative 2 and 6, negative 3 and 4. You don't even have to look at the other combinations because then the numbers begin being larger on the negative side. So out of these, the sum of positive 4 is equal to this set, and so those become your two terms. And so the factored form for that expression is as follows.